Welcome to this video on Leap Bridge Steel Connect Edition analysis using finite element methodology. So first thing you do once you open the analysis window is go ahead and set the type here to finite element. You can set the dynamic load allowance for both the design and fatigue trucks, and then you have analytic control over the live load analysis here as well. So not only can you tell whether or not to include it, but if you do include it, then you can go about the process of doing the lane setup, defining the multiple presence factors, and define the FEM mesh settings for the deck and the beams. Let's take a look at lane setup. Here in lane setup we have three options here for the lane layout. You have fixed, mirrored, and floating. So let's start with fixed. Regardless of the option you pick, you'll set the minimum lane width, and then you'll also define the travel way or travel ways depending on the structure that you have. So you can define up to 2 different travel ways. Within each one, you give us a left and right reference for where to place the trucks, or basically where is the edge of the travel way, and then from that we'll define the lanes and the truck locations. So for this one, the default option is to do what it's always done in the past, and that is to move the truck from the very left edge to the right edge of the deck. Now you do have options here for defining those references and offsetting from those. It could be left or right edge of deck, it could be relative to the alignment the bridge is defined along, or it could be along or relative to either parapet. So in this case I'm going to tell it relative to the left edge of deck I want to move over, let's say, 1.5 feet. Do the same thing from the right side of the deck and apply. Now once I apply that value, once I zoom in here, we can see where in the fixed methodology where those 3 lanes are located. So it tells me that I have 3, what I ended up with were 12.5 foot wide lanes, and it will set the vehicle path to consider both the left, the center, and the right side of each of these lanes. The key thing here is that once you make changes up here, remember to select apply for those to take effect. For example, if we go down to, let's say, floating, again I can set these values as I like. Right now I have just the one roadway defined, nothing really changed until I select apply. Once I select apply, it updates the possible number of lane combinations. In this case I ended up with 32 different combinations, and then it shows me graphically where each of those are located. So I can graphically jump in here. I can select any roadway from the list here and see where the resulting lane or lane configurations are located. Once you have this set the way you like, you're going to go ahead and select OK. So I'm going to go back to fixed, apply it, and select OK. As mentioned earlier, you can set the multiple present factors. You can set these or change these. The defaults are going to be based on the LRFD code, but you can change those. And then for the finite element mesh, you can set the mesh size for the deck, the girder webs, and then that mesh element tolerance. You have an option here to include the haunch and the section properties. You can preview the analytical model, and it'll generate a show you what that mesh will look like for the model, and you can either view that here as kind of a wireframe model, or we can do a solid fill on that model and let you review what that resulting mesh is going to look like. From there you're going to go ahead and kick off the analysis at that point. So I'll go ahead and select run analysis and let it start generating the model for me, run the analysis, and return the results here back to Leap Bridge Steel. Now that the analysis is completed, you can go one of several routes from here. As you can see, we can review the shear and moment diagrams and displacement for this model. We can do that for any stage and any either load case or combination. So again, it's simply a matter of selecting the load case you want to consider. So let's say we'll do the self-weight of the slab or the HL93 truck, either one. Again, you can look at the shear moment diagrams. You can enlarge that scale if you want. You can take a look at the moment diagrams for it. Like I said, the shear diagrams. We can do that for all the girders concurrently, or you can tick that off and look at it for all the members, one being a primary member and the others kind of being ghosted in there. Or you can view just a single member straight on and select the member that you want to review. You can also add the option here of 10th points and get the values reported back at the 10th points as you move along the report here. You can also review textual reports, so you can go to the Show Reports button, select either dead load or live load, and review any of those reports that you want as well. So let's say I'll select girder forces. That will go ahead and open up the report window. And here in the report window, you can tell it for what girder you want to do this for. You can do it for all of them. For what stage, for what load case. You even have POI options here, such as things like equally spaced locations, at the section breaks, where the cross frames are located, and so forth. So let's say I'll just do equally spaced and have it go ahead and generate the shear and moment diagrams here as well. Go ahead and submit that, and that will go ahead and generate the report. Again, very easy to do. Once you generate this report, you have options of exporting it out to PDF, a web page, a spreadsheet, a CSV file, or even an ASCII text file. So a lot of different options here for either exporting or emailing that file to a colleague in the same manner. So thank you for watching this video on Leap Bridge Steel Connect Edition's finite element analysis tool.